Large language model. What is large language model? How it works? How does memory comes in picture? What is the short-term memory versus long-term memory? And how large language model interacts with vector database. So these are the topics that I will be discussing today. Hi everyone, I'm Rakesh Theatre and welcome to Theatre Essence. A large language model, also known as LLM, is a neural network designed to understand and generate human-like text. In simple terms, it consists of several layers of neural network, each layer performing mathematical transformations on the data. So, large language model identifies patterns from huge amount of data and eventually store the knowledge in terms of weight. Common examples of large language models are GPT, BERT, T5, Llama. So GPT is the generative pre-trained model from ChatGPT. BERT is the bidirectional encoder representation transformer from Google. Another one is the text-to-text transformers from Google again. And Llama is from Facebook. So we can compare large language model as a human brain, which is able to process input data, text, and then generate the output data, response text. Next, moving to layer. Layer is the building block of neural networks. By stacking several layers together, it forms a full model, also known as large language model. Since it contains several layers of neural network stacked together, it is often known as deep learning. Deep in a sense that you have multiple layers of neural network stacked together. A layer takes an input tensor. It applies the mathematical operations, example, multiplying, weight, and processing through activation functions, and then produce an output tensor. When compared to human body, you can use organ as the layer. An organ in human body carries energy and materials to different parts of the body. So same way, layer takes an input tensor, processes it, and generates an output tensor. So what is tensor? A tensor is a multi-dimensional array used to represent all the data in the neural networks. You can consider the input data, the output data, the activations, and the weights. All these can be considered as tensor. Compared to human body, you can consider blood as the tensor. Blood carries energy, signals, proteins to different parts of the body. So same way, tensor carries data to different layers of neural network. So let's look at an example of few tensors, how it is represented and how it is stored. So the first example of tensor is the embedding matrix. It's a two-dimensional matrix. Embedding matrix here, you see I have two rows. The first row represents the first word and the second row represents the second word. So the second one is the attention weights. So this is another tensor and it's of 3D type. In this you have collection of batch and each collection represents collection of tokens. So same thing, just like we represent a list of numbers as word here, we are representing token as a list of numbers. The third one is the transformer feed forward tensor. It could be 2D or 3D tensor. And in the example, the feed forward weights, we are showing three features represented by numbers. So the first row represents the feature 1, and the second row represents the second feature, and so on. This is how large language model represent and store data. So the first thing that it does is it processes the user input, breaks into words. Each word is further converted into tokens, and then each token is converted into vector embeddings, which is collection of numbers. So overall, compared to human body, we have brain as the LLM, organ as the lawyer, and blood as the tensor. And these are the core aspects. To continue further, in my previous video, I discussed about what are the different types of neural networks and what are different types of learning algorithm. If you are interested, please watch the video. Now coming back to the picture, we have the inputs in the front. These are input tensors, and we have the output at the end. Those are the output tensors. In the middle, we have several lawyers, which is also known as the hidden lawyer, and each of the lawyer has their own functions and process the input data and generate the output data. Next, memory in large language model. Large language model have two types of memory. First one is the short-term memory. The second one is the long-term memory. The short-term memory is also known as the context window, and this is what made the ChatGPT popular. So the invention of context window made ChatGPT possible. That's the core difference between Google search and ChatGPT. Context window, or the short-term memory, is the memory optimization technique. It stores the computed key value pair. So by using the catch key value pairs or the data, large language model reduces the redundant operation and also helps to generate the faster response. For example, in GPT 3.5, it is able to store approximately 4,000 key value pair data in short-term memory, and in GPT-4, it is able to store approximately 128,000 key value pairs in the short-term memory. Moving further, we have millions and billions of customers who use ChatGPT, and it needs to process and generate response faster. So due to this, ChatGPT applies multi-tiered memory strategy. So in the multi-tier memory strategy, the first one is the GPU memory, which is the graphics processing unit memory. It is used to store active and very frequently used data for minimal latency. So this is the real-time data that it stores. However, this is very expensive. Second layer of memory is the CPU memory. Under this, we commonly use RAM, or we could also use as solid state drive memory, SSD memories. And this is used to store less active and less frequently used data. This does not refer the real-time data. Distributed cache is common in most of the system, and the main purpose of this is to store conversation history or user session data. So this is the last layer. Next, in long-term memory, it uses vector database to store the huge amount of key value pair data. So in this case, the key value pair data are stored in vector database. So due to this, LLM is able to retrieve the data from vector database quickly, and that's how it behaves, as it can remember the user history and conversation. Like I mentioned in my previous video, vector database use vector indexing using algorithms like nearest neighbor, and that's why it is able to search faster and find similar things In addition to the short-term memory context window and the long-term memory, there is one more concept that we need to understand. In terms of key value pair catch, you need to preserve the latest data in the GPU, and you need to move the old data out of the GPU memory. You need to offload the old data from the GPU to the CPU or to the distributed cache memory. To further understand this, we can use the rate limiting bucket approach. Consider you have a bucket. It can hold certain amount of water. So you have new water that is flowing inside the bucket, and at the same time you have old water flowing out of the bucket on the bottom. So new data comes from the top, and on the bottom you have the old data flowing. So this is how you control and maintain the latest data in the key value cache. Next, we will deep dive into how large language model works internally with and without vector database. So in large language models without vector database, the first step is the tokenization, where user input is converted into tokens. The second step is the embedding lookup, where token is converted into vector embeddings. And then, as I mentioned, in large language model, it has several layers of neural network. So once you have the vector embedding, it then passes the vector embedding to each layer, and each layer will process and produce the output tensor. So in this process, if you are asking ChatGPT question for the first time, then it does not have any previous memory. So in that case, it simply applies matrix multiplication with weight tensors. This output tensor is passed through nonlinear activation functions and attention mechanism at the end. In attention mechanism, it is able to store and generate key value pair data, short-term memory or the context window. It will decide how much tokens or the vector embeddings should be used from the short-term memory to generate the output. Consider a second case where you ask the question second time and it has the memory from the previous question, right? So you are asking a relevant question again, second time, and it has the understanding of short-term memory for the first question. So in this case, LLM, large language model, pass the attention mechanism to each layer, and each layer will decide how much information or the tokens to use while processing through the layer. The fourth step is the output probabilities. In this, the output tensor from the previous layer goes through probability distribution process called softmax. And then in the fifth, it picks the highest probability token. Fourth and fifth refers that if you generated a good response, then it returns that good response back to the user. However, if you feel that the response is not good enough, then it can repeat the process. This is how LLM works internally without vector database. Next, let's understand how vector database and large language works together. So in this, the first step is same, which is tokenization and embedding, finding the tokens and finding the embedded vectors. Once you have the embedded vectors, the second step is to search that embedded vector in the vector databases. For example, let's say you're asking a question, what's the latest iPhone model? And so it will retrieve the key value data, and the response would be iPhone 16 launched in September 2025. And then the final answer that it needs to return to the user is iPhone 16 launched in September 2025. If you find the answer not reliable or not good enough, then you can pass the answer back through the LLM and figure out a better answer. So this is what the fourth and the fifth states discuss. I hope the information that I presented today is useful. Kindly subscribe to Data is sense. Thank you and stay safe.